Hello, today we're going to talk about 3.4, multiplying polynomials. So before we begin, let's refresh our memory on the distributive property. Remember we said that A times B plus C would give us AB plus AC because we had to distribute A into each of the terms in the parentheses. Now let's look at why this works with integers. For example, if we had 2 times 1 plus 3, where 2 is A, 1 is B, and 3 is C. We can distribute the 2 into each term. So 2 times 1 is 2, 2 times 3 is 6, and that gives us 8. Similarly, we would just write, instead of 1 plus 3, we could write 4, and that would give us 8. So that you can see how the distributive property works with integers. So why is it that when we're doing integers, we can just add it to 4 and do the math, but why do we have to use the distributive property with polynomials? Well, that's because if you look at this polynomial, these aren't like terms, so you can't combine them like how we combined 1 plus 3. So we actually have to use the distributive property in order to multiply. So what that means is this x, we would have to distribute into all 3 terms. So what would we get? Get x cubed plus 2x squared minus 5x. And this would be our final answer, a polynomial in descending form. So now let's take a look where we have a binomial and a trinomial. Same thing. You're going to have to use the distributive property. Now in Apex, they want you to practice rewriting the expression using the distributive property. So let's see what that means. So just like before, we'd have to take this x and distribute it into all 3 terms. And you'd also have to take this 4 and distribute it into all 3 terms. And you also have to be able to go the other way. Now what does that mean? Remember, when we multiply numbers such as 2 times 1 times 4, it doesn't matter the order, right? We can do 1 times 2 times 4, we can do 4 times 1 times 2. It doesn't matter, we'll still get the same answer. So if we're going from here and distributing it, we have to go the other way, where we take this and distribute it. Okay? So let's see how that would look like. Well, first, we'd have to take x squared and distribute it into 2 of the terms. And then 2x and distribute it into these 2 terms. And lastly, take negative 5 and distribute it into these 2 terms, okay? So you have to be able to go from here and distribute into here, or start here and distribute into here. This is something you have to be comfortable with because this is what Apex will ask you to do on the checkup and the quizzes. So let's see what that would look like. Let's do x. We have to distribute it into all 3. So what would we get? We would get x, and we can write it like this without actually solving for it. Now what else do we have to distribute? We also have to distribute the positive 4. So plus 4, and we're distributing it into all 3 of these terms. So this is how you would rewrite the expression using the distributive property. Remember, we're not solving yet, we are just rewriting it using the distributive property, okay? So this is when we start on this expression and distribute into here. Now remember, we also have to do it the other way. So let's see what that would look like, where we start from here and distribute it into here. So first, we start with x squared, and we're distributing it into x plus 4. What's next? Positive 2x. And then we also have to distribute that into x plus 4. And lastly, negative 5. We have to distribute it into x plus 4. So both of these are ways to rewrite the expression using the distributive property. We're just going in both ways, and you have to be comfortable and be able to recognize both ways because you will see it on Apex. So now let's get into solving these polynomials. So one of the ways is using the table method, where we write a table. So let's do the first polynomial, x squared, and let's give each term their own space. Minus x, right? It's not just x, it's negative x. And positive 1, okay? Now we also have 2x squared and positive 3. Okay, so our table can look something like this. And now we can multiply. So x squared, we can either go this way or go this way, whatever's easier. So 2x squared times x squared. That would give us 2x to the power 4. Now 2x squared times negative x, negative 2x cubed. 2x squared times 1 is just 2x squared. And now positive 3 times x squared, 3x squared. Positive 3 times negative x, negative 3x. Positive 3 times positive 1 is 3. Now, why did we do the table method? Well, this is really the distributive method. Do you see how we took the 2x and distributed into all three terms? Yeah, right here, 2x squared, and we multiplied it with all three. Same thing, positive 3, we have to distribute it into all three. And we see that in the table where we take positive 3 and we're multiplying it with all these three terms. So this table method is using the distributive property. It's just another way to look at it. Okay, so we're not done yet. We have to combine like terms to simplify our answer. So remember, our answer is written in descending order. So what are we going to look for? We're going to look for the term with the highest degree. And I see that it's 4. So we'll write 2x4. And I don't see any like terms, so I'm just going to leave that. Next highest degree is 3. So it's minus 2x cubed. Now I don't see like terms, so let's move on. Next highest degree, 2. I also see a like term because they both have the same degree and variable. So now we can combine 2x squared and 3x squared to give us 5x squared. Next, we have negative 3x with a degree of 1. And finally, our constant, which is a degree of 0. So this is our final answer, a polynomial written in descending order. Now let's look at the second method, where we are multiplying vertically. This is very similar to multiplying integers vertically. For example, if we wanted to multiply 121 times 22, we would multiply vertically, right? Take 2, multiply by each of the digits, and then take this 2 and multiply with each of the digits. Same thing. So let's rewrite this. 2x squared minus 4x plus 1, and we're multiplying it with x minus 2. So same thing, we want to focus on, let's just focus on this term, negative 2, okay? You have to be careful with your sign. And remember, we are distributing it into all three terms. So just like the table, multiplying vertically is just another way to look at this, to look at the distributive property, okay? So we're going to take this negative 2 and we're going to distribute it into all three terms by multiplying it this way. So what is negative 2 times 1? Well, that's negative 2. Negative 2 times negative 4x, that is positive 8x. And negative 2 times 2x squared, that is negative 4x squared. Okay, so our first line has to do with negative 2. Now let's focus on our second one, our second term, x, right? Because we took this 2 already and distributed it, so now we also have to take the x and distribute it. So let's go ahead and do that. X times 1 is just x. X times negative 4x, negative 4x squared. And x times 2x squared, positive 2x cubed. And now you see it lines up very nicely. You line up your like terms very nicely. And the reason why I left this gap here is because remember, when you multiply numbers, 2 times 8 is just 16, 2 times 4, 8, 9. And remember, you put a 0 and then you go on to multiply 2 times 8 and so on. So putting that 0 placeholder is exactly why I left a gap here. It's very similar to multiplying integers. And the reason why we create this gap is so we can better line up our like terms. And you can see our constant, this is our only constant, so this is -2. And these are like terms, 8x and x, because they have a degree of 1. So this should be positive. Okay, so 8x plus x gives us 9x, positive 9x. And now we have -4x squared and -4x squared. They both have a degree of 2, so they are like terms. So this gives us -8x squared. And lastly, we have positive 2x cubed, because there's no other like term. So this is our final answer, a polynomial written in descending order. And remember, you have to write your answers in descending order, and you have to make sure you are combining like terms.